video, we are going to explain about a project titled Regression and Classification of Alzheimer Disease Diagnosis using NMF TDNet features from 3D brain MR image. This project presents a comprehensive overview of Alzheimer disease, a progressive neurodegenerative condition affecting the elderly and characterized by cognitive decline and memory impairment. Emphasis is placed on the significance of early AD detection and the role of non-invasive medical imaging, notably the MRI images, in assessing the change in brain structure and the metabolism. This study delved into the real life of MRI-based computer-aided diagnosis for pinpointing the AD stage and explored the integration of deep learning techniques into the medical imaging for enhanced AD diagnosis. A novel approach termed the NMF TDNet is introduced to extract the features from the 3D MR images, enabling the accurate classification of AD and prediction of clinical scope. By leveraging the advanced imaging and the cutting-edge AI methods, this research contributes to the advancement of AD diagnosis and understanding. This research introduced an innovative approach named NMF TDNet designed to extract the discriminative features from 3D MR image for accurate Alzheimer disease classification and the clinical score prediction. Unlike the conventional methods employing the principal component analysis, NMF TDNet adopts the non-negative matrix factorization to construct the multi-level filter bank processed through layer-wise convolution. This process generates the convolution outcome that contribute to forming a higher order tensor. Subsequently, the tensor decomposition is harnessed to reduce the data dimensionality, resulting in refined image features. These extracted features are then employed as an input for the support vector mission for AD diagnosis and clinical scope prediction. Remarkably, experimental outcomes demonstrate the NMF TDNet superiority over PCA-net, which relies on PCA for the feature extraction, affirming its potential to significantly advance the AD analysis and the prediction. These are the basic requirements that are needed to build this project. The software requirements are Python IDEL with version of 3.7, Anaconda with version of 3.7 or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the package. Here we need to import the essential libraries and packages that are to facilitate the data manipulation, analysis and model building for the Alzheimer disease diagnosis project. And the next step is exploring the dataset. The dataset containing the 3D brain MR image for Alzheimer disease diagnosis is thoroughly explored. And the next step is image processing. Here, raw brain MR images are processed to ensure the uniformity and suitability for the analysis. This involves resizing the image, normalizing the pixel value, and converting the images into arrays. And the next step is data extraction. Relevant features are extracted from the pre-processed image using the processed NMF TDNet technique. This step focuses on capturing the essential information that can aid in Alzheimer disease diagnosis. And the next one is appending. Extracted features are appended to the dataset, creating a new dataset with both original MR image and the extracted NMF TDNet feature. And the next step is splitting the data into the train and the test. The dataset is divided into the training and the testing set. The training set is used to train the model and the testing set is reserved for evaluating the performance. And the next step is building the model. Various models are built. The first one is MobileNet. It is a pre-trained convolutional neural network architecture designed for efficient and lightweight image classification tasks. And the context of this project, it be fine-tuned to classify the Alzheimer disease based on the extracted features. And the next one is PAC-net based Inception ResNet v2. It is a custom model architecture inspired by the Inception ResNet v2 CNN with the additional position attention correlation layer. This architecture enhances the feature extraction by incorporating the attention mechanism and the correlation among the features, which be the advantageous for diagnosing the Alzheimer disease using the complex 3D brain MR image. And the next one is NMF TDNet using convo layers. This is a specialized neural network architecture designed for extracting the features from the 3D MR images. It employs the convolutional layer to process the image and generate the informative features, which effectively process the 3D brain MR image, capturing the essential pattern and the structure relevant to the Alzheimer disease diagnosis and the regression task. And the next one is SVM. It stands for Support Vector Mission. Is a classic machine learning algorithm for the classification task. It aims to find a hyperplane that best separates the different class and classify the Alzheimer disease based on the extracted features, providing the interpretable and reliable classification result. And the next one is SVR. It stands for Support Vector Regression. Is used for regression tasks. It aims to predict the continuous value by finding a regression hyperplane. It predicts the clinical score related to Alzheimer's disease progression, enabling the estimation of disease severity from the extracted feature. And the next one is decision tree. It is a machine learning algorithm that partitions the data based on the feature condition and predict the outcome based on the majority class in each internal node. And it is used to classify the Alzheimer's disease based on the extracted feature, providing the simple yet interpretable result. And the last one is voting classifier. It combines the prediction of multiple individual models, in this case decision tree, XGBoost and the gradient boosting models are combined. It enhances the classification accuracy and the robustness by leveraging the strength of the different models for Alzheimer's disease diagnosis. And the next step is user gives the input. Here we used the Flask as a web framework where the user provide the input, which it include the Alzheimer's disease diagnosis. Here we are giving the input in the form of image. And the next one is the given input is pre-processed for prediction. The provided user input undergoes the pre-processing similar to the training data, ensuring the compatibility with the trained model. And the next one is trained model is used for the prediction. The pre-processed user input is fed into the trained model to predict the Alzheimer's disease diagnosis depending on the task. And the last one is final outcome is displayed. The prediction from the different models are consolidated and presented as a final outcome. This outcome indicates the predicted Alzheimer's disease diagnosis or clinical score based on the user input. And the execution of the project. To execute the project, first we need to open the code folder, and this is the code folder containing of various files within it, the dataset folder containing of the images within it, and the static folder containing of CSS, fonts, images, JavaScript folders within it, and the template folder containing of the HTML documents. It typically include of home, index, result, sign-in and sign-up pages within it. And the app is an py file which likely contain the information related to the front-end logic. It includes the code written in Python that handle the server-side operations such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the test case is the folder containing of the various images that will be used to test the performance of the model. And the model is a pickle file which contains the algorithm information and is loaded into the project code during the runtime to utilize the trained model for the various tasks such as making the prediction on the new data and performing the specific operation. And the notebook is an IPYNB file which contains the combination of code, graph and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the signup.db is a file appear to be the database file used to store the user information. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command that is cd space and paste this code folder path. By this it will change the current directory to the code folder path. And then click on the enter button. Here we need to write a command that is python space app.py. By using this command, we will execute the Python script and perform the runtime check for any syntax errors or logical issues. And then click on the enter button. After running this app.py file, the Flask framework will host the application locally at the default address like this. We need to copy this link and paste it on any of the web browser of our choice, and I prefer to use Google Chrome. I'm pasting this link and then click on enter button. Here it redirected to this page containing of some information and title of the project. Then click on the sign up button. Here it will redirect to the sign up page containing of some input details that are need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here it will redirect to the sign in page containing of the username and password, and we need to fill those details and then click on the sign in button. Here it will redirect it to this index page containing of the choose file and upload buttons. Click on the choose file button, it will redirect it to this page containing of some images within it, and we need to select one and then click on the open button and then click on the upload button. Here it redirected to this result page containing of the prediction of the image as of moderate demented, and by using the try again button redirected to this page containing of choose file and upload button. By clicking on the choose file button, we redirected to this folder. Here we can select the another image and then click on open button and then click on the upload button. Here it redirected to this folder, this result page containing of the prediction of the image as very mild demented. In this way, we can classify the Alzheimer disease by using the deep learning algorithms. And in conclusion, the proposed method NMF TDNet yields superior performance than of TDNet for the feature extraction from the 3D MR images to classify the Alzheimer disease and predict the clinical score. The proposed method uses the non-negative matrix factorization instead of principal component analysis to construct the multi-level filter bank to process the input image by layer-wise convolution. The convolution results are then used to build a higher order tensor, and then tensor decomposition is used to reduce the data dimensionality, producing the final image features. The experimental results show that although the NMF TDNet yields far fewer features than PCNet, using the NMF TDNet features as input achieved superior performance than using the PCNet features as input.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.